We have a question here that asks us to state the maximal domain and range, and then to sketch a graph stating the range. So there's a lot of stuff we have to do. First, we need to state the maximal domain. If we don't do that, then we're going to end up in trouble with the examiner. Then we're going to need to sketch the graph and then state the range. So first of all, let's have a look at these relations. And these relations are carefully chosen for a given reason. And so we need to have a think about these relations, and they come with a warning, which is why I've drawn a warning sign here. First of all, if you ever get a square root sign, we know that we can't take the square root of a negative number in maths methods. So therefore, we know that this has to be 0 or positive plus VE underneath this square root radical. Otherwise, it will result in much sadness. Also, if we have a fraction, if we put something underneath, we know this denominator cannot equal 0. Otherwise, buildings will fall down. And the third function that we may not have talked about yet is when we have log of something. And when we have a log, we know this must be greater than 0. It cannot equal 0, and it cannot be negative. So when we see these functions, it's really good if an alarm goes off in our mind to remind us that we are going to have something special going on with the domain. So with that being said, now let's have a look at these relations. First of all, we know that this is a positive square root graph, which means it's going to look something like that, with this point being my 0 point. We know that underneath the square root can't be negative, so we're looking for this point. And at this point, this is where my square root will equal 0, which means at this point, 2x minus 5 will equal 0. Therefore, 2x will equal 5, and therefore x will be 5 on 2. Now what it tells us is that this square root won't function if x being 5 on 2, if x is less than 5 on 2. As soon as x is less than 5 on 2, our whole square root becomes negative. So I know my x point for this must be where x is 5 on 2. Now x is 5 on 2. When x is 5 over 2, y will equal the square root of 2 times 5 over 2 minus 5, which is 0. So I know my point there will be at 5 over 2 and 0. So that means my function or my relation is going to look something like that. But of course, we can't just do some scribble and expect to get the mark. So let's answer the question properly here, and I'll do that in this space. So first of all, the maximal domain. So let's call that part 1 of the question. Our maximal domain that's our x values, of course, will be x, so that x is greater than or equal to 5 on 2, all the way to infinity. And so there's my answer using my square bracket to say it includes 5 on 2, and my round bracket because infinity is a concept, not a number. Secondly, it says sketch the graph, and if I'm going to do that, then I need to get my ruler out because examiners don't like it when you don't rule your lines. So here we go, trying to do that. So now my graph is ruled. My axes will be labelled y and x because that's always the right thing to do. My important point there, which is at 5 over 2 and 0, always better to use coordinates than just write the number. You can never go wrong. And my line's going to look like that. And to make sure I get the grab, I'm going to write the equation of the line in there. And that should send the examiner into raptures. And finally, the range of this function, well, you can see the range starts at 0, including 0, that's why that's a coloured in dot, and it goes all the way to infinity. So I can say the range is from 0, square bracket to show it's inclusive, all the way to positive infinity. And that's how I can successfully answer part A. Now let's have a look at part B. Here again we have to be really careful with our function because we know we have a bottom line that can't equal 0. So we can say here the denominator, let's do some thinking, the denominator equals 0 when 2x minus 5 equals 0. Therefore, 2x equals 5 and x is 5 over 2. So because the denominator cannot equal 0, therefore x can never equal 5 over 2 for this function. We know it's a hyperbola, and we also know it hasn't been flipped around or anything. So our translation will be so that our asymptote will be at x is 5 on 2, and because it hasn't been translated up or down, because that would require a plus or a minus out here, we know that the y asymptote is on the axis. So now let's sketch the graph. So here are our axes, all beautifully ruled, of course. I'm going to label them again, y and x. I'll draw in my asymptote, which shows that x can't equal 5 over 2. And here you'll see the danger of not using a ruler, because that's not the straightest line you'll ever see. That's it, x is at 5 over 2, if you can read that. And my hyperbola is going to look like this and like this. I'll label it y equals 1 over 2x minus 5. And remember, I'll need to find my y-intercept. So let's do that. My y-intercept is where x equals 0. So therefore y equals 1 over negative 5 or negative 1/5. So again, we'll write these down as coordinates, and I have my y-intercept. So now let's make sure we've answered the question. 1. The maximal domain is actually all numbers, but not including 5 on 2. So I'm going to write that as real numbers, not including 5 over 2. And that's probably the best way to do that. Part 2 is the graph, and that's all beautifully drawn to everyone's satisfaction. And part 3 asks me what the range is, and the range of my y values, which is everything except for the x-axis, which is where y equals 0. So the range is real numbers, but not including 0. And there I've written the domain and range in the first part using brackets, and in the second part using set notation. If you found this video helpful, please subscribe or like. Thanks.